The Math Map Book Club, where ordinary parents encourage one another to develop an extraordinary appreciation of math. We love what we know and struggle over the unfamiliar. Through weekly conversation and exploration among friends, we can begin to enjoy ideas that seem difficult. Join our book club as we discover how math helps us to know God and to make Him known.
Hello, I'm Lee Bordens, and it's Wednesday, October 30th, 2024. Welcome to the Math Map Book Club, where Kirsty Gilpin and I discuss lessons each week from our math curriculum for families with students enrolled in classical conversations communities. This academic year is actually the academic semester is almost coming to an end, and I'm sure all of you are looking forward to a break where you think you'll do a lot more math, but maybe you won't, but at least review our videos. So Kirsty, what do you have for us today?
I am going to share. There we go. We are on lesson 14, and that is about constructions. And as Lee pointed out, this is our last but one, not our last but one call for this semester, but our last but one call for this semester's lessons. And so we recently had somebody share a testimony about the fact that they were actually keeping up with where they were supposed to be, which had never happened before for them for math. And so that idea of actually having a break was something real. And that's excitingly, I think, that you have created this curriculum that actually matches that challenge calendar and gives families that opportunity to go back and revisit ideas or just enjoy math in the world around them for a little while, because that mental break is so important. And I think you've done that by putting constructions here too. So we've talked about polygons and triangles and angles and lines and circles, and we're going to take all of those ideas and we're going to review how they may work together using these ideas of constructions. And so it's a really great capstone type of experience for the semester and a great preparation for students going into the Blue Book week, because it's going to take those ideas and really encourage them to integrate and think through and review. So as always, we want to take a minute and make sure we remember where we are on our math map. And so as we look here, we are almost halfway through. We are on lesson 14. And then as we emphasize every week, we are using the complex lessons. But one of the many beautiful things about the math map is that you have the flexibility to use any of those domains, to use the domain that is going to be the most beneficial for your child and for your students, for your families, but still talking about the same ideas. So moving on and talking about our interesting integer, this week I chose 28. So let's go ahead and open it up. And what are some things that you might want to share about 28? And those questions are there as just some possible prompts.
Well, 4 and 7 are factors, as well as 1 and 28.
I often feel like our months should just all have 28 days. It would be so much easier to keep track, but I guess that math doesn't work.
It's half of 56. And a tenth of 280.
How could you take those? So those were expressions. So just to review, those were expressions, right? 1/10 of 280 or half of 56. Those are expressions. How could we write an equation? So especially for those of you who are maybe doing this exercise with students who have some algebraic experience or a little bit older, how could you write an equation that would tell us something about 28?
You could expand it and say 2 10s plus 8 equals 28.
I could. could I say that 2x's or 2 times x, 2x equals 56? Or that 1/10 x equals 280? Or rather,
I
10
see where
x
you're
equals
going.
280,
Mhm.
right? So there's a way that we can take that same exercise, and for our younger students, they maybe come up with some expressions that are all numerical, but older students can maybe write an equation. And your even more experienced students might take those factors like 4 and 7 and say x minus 4 times x minus 7 equals x squared plus 11x plus 28, right? So I get my 28 that way. So there's different ways that we could take that and play with it algebraically as well as arithmetically. So Jana pointed out that 28 days is kind of our lunar month. And so we see that 3 out of 4 years in February. Does anybody know something interesting about 28 in the Bible? There are 28 authors of the Old Testament. So 28 kind of pops up. So
I don't
another,
think I ever think of the number 28 with the Bible, so now I'm going to look for it.
how about any other books? Has anybody seen 28 in any other books?
Leslie said Romans 8:28.
Yeah, I'm thinking of it maybe not as a significant number, but as, a scripture associated with it.
No, I think that's beautiful. Especially, not that every verse isn't significant, but
Right.
verses that really stand out to us, right? That's great. Yeah. So here's an interesting fact that I didn't know, but they say that 28 days is the standard curing time for concrete, which is kind of interesting when you look at it and you kind of connect that to that idea of a lunar month, right? The concrete, right? Like that to me is it coincidental? I don't know. It was interesting. Last week we talked about happy numbers, and this week we're going to talk about perfect numbers. Now, perfect numbers actually do also show up in the charts. So if you want to go back and look at chart 5.3, you'll see that we define perfect numbers there. But let's go back. And so Lee started us off with our list of factors. So what are the factors or divisors of 28?
4,
2,
3, 4, 7, 14.
28.
And 28, right?
Yeah.
I'm going to put 28 here because for this purpose, we're not going to use 28. We're going to use what they call proper divisors, which are all the numbers except for 28, except for the number itself. But if we were to add these up, what is the sum?
Including 1?
Including
20.
1, but not
Okay,
28.
yeah.
28.
It is indeed 28. Is that cool? So that's what we call a perfect number. And 6 is the first perfect number, but I didn't want to just pick 6. So I went for 28, which is our second perfect number. So
Because 1 plus 2 plus 3 equals 6. Is that how you do
yes,
it?
that's how you do it. Yep. And then we have that same process. We can talk about abundant numbers, which means that their factors sum to more than the numbers, and deficient numbers, their factors sum to less than the number.
I did think about summing these two because this is when my kids were little, we did a game where we would find all the pairs that equal 10, because that's kind of a helpful thing when you're, doing bigger numbers to know which add-ins will come to 10.
So just some things that we can think about, right? So now that we know about perfect, deficient, and abundant, we could look at other numbers and determine which one of those buckets they fall into. Well, hopefully we'll all look at 28 a little bit differently. Let's go ahead now, and that we've warmed up our number brains, and take a look at our cover. And what do we see here in our art, and why do we think we maybe chose this for this week?
Well, it looks like he has a compass in his hand. And since we're going to be using some tools, maybe.
Yeah, he's drawing, I think, a map. And you see the globe in the back. So he's making maybe navigating or something. Yeah.
So our title is called The Geographer. So yeah, I think that's probably accurate.
He's using a compass. He's holding a compass in his hand, and that makes me know that he's trying to do geometry.
And maybe he's up high because he's looking out the window, and maybe he's overlooking the land which he is mapping out.
Excellent.
There's also some, I think they're Roman numerals, it's hard to tell, in the background on the wall.
So I heard that magnifying glasses are now cool again because of Joanna Gaines. So that popped up in my feed. There's one at Target on clearance in case anybody needs to know that. But for those of us whose eyes are maybe starting to get a little bit older, right, there we go. We might, a magnifying glass might help us there to decipher those Roman numerals.
I think this is another artwork where the way he's gazing out the window gives that sense of infinity and ongoingness.
I like that. Is accuracy important in drawing maps?
Nathaniel Bowditch would say so.
Why? So what are some of the consequences that may come from a poorly drawn map?
You could get into an area of danger or find yourself against the rocks somewhere if you're navigating, for instance.
Fall off a cliff.
Yeah.
Die of thirst.
Right.
Even
So
if you're
go ahead.
Even if you're just drawing a map for a friend to get from one place to another, if you don't have at least close proportions, they'll think they're on a short road, that they're going to be turning very quickly and they might need to be on that road for miles. So how long, if you're actually using it to scale, you would want to know how long am I going to be on this road before I do the next thing.
So we definitely see that there's some physical requirements, right, for how we move in our world and how we interact with maps, right, that we want it to be accurate. How about political maps, boundaries? What happens if you had two maps that had different boundaries?
Get war.
War, yeah.
Yeah. So there's a need for accuracy when we're drawing maps. So when we think about constructions, one of the big ideas that we can think about is the fact that we're working on being very, very accurate when we construct something. So Jill's husband is a structural engineer. And so Jill knows firsthand how important it is that our measurements and our drawings all be exact, because our houses may not fall down if our walls are a little bit out of true, right? But it's certainly hard to wallpaper. But we've also seen stories where buildings have collapsed and terrible things have happened when loads aren't done properly, right? So that idea of the engineering and how precise we want to be is really important. So when we think about construction in general, that precision and accuracy is very important. And so that idea carries over into what we're talking about this week with constructions, because what we're going to look at is how do we use tools of geometry to draw something accurately, right? Not just a general idea, right? So you're gonna see as you get into the lessons the difference between drawing, sketching, and constructing. So if I'm sitting with a friend and I maybe want to give them a quick idea of what my house is like, I might sketch something. And I might sketch it so that my bathroom looks bigger than my bedroom, right? But I just say, don't worry about that. This is just the general layout. There's my sketch, right? I give you extra information to tell you things about what I've sketched out so that you're not depending on the drawing. But then if I was to want to take that sketch and actually draw it to give to an architect, I might actually use a ruler, right? And draw straight lines. And I might try to make things as proportional as I can and measure things out so that when I give it to the architect, he knows that really I don't want my bathroom to be bigger than my bedroom, right? He knows the proportions that I'm looking for. And then my architect or my engineer is going to have to take those drawings now and he's going to make them really precise so that materials can be cut and the building can be built so that it's strong and doesn't fall down, right? So there's a kind of a layering there from a sketch or a drawing to a construction. And that's the same idea we're going to talk about this week. So as we look here at our invention page, and we really want to remember what we're looking at when we talk about our invention page is practicing those skills of learning. And on this page, it's a great page for comparisons and definitions. So let's take a look at two words here, measure and direction, and let's try to define those. So when you hear the word measure, what do you think that we're talking about?
I think of units, how many units, either inches or centimeters, particular precise.
To find the length.
Length, right? And so if we're talking about length, what kind of a figure are we talking about?
2D.
2D, or sometimes, actually, yeah, just 2D.
Are you sure it's 2D?
It can be 3D because you can have depth, right?
Okay, so if I'm having multiple measurements, I might have, right? But if I'm just measuring one length.
1D. 1D.
1D, right? So when we're thinking about one length, I'm thinking about one dimension. So when we talk about duplicating a measure, what kind of figure do you think I'm going to duplicate?
A line?
A line. Segment. Yes. A line segment, right? Because a line is infinite. So we want to just duplicate a portion of that line segment. So how about direction? What do you think about when we think about direction? And if you want a hint, you can either look at the page or you can think back to when we talk about vectors or coordinates, and we talk about polar coordinates, and we talk about there's a length and there's also what else is there? A magnitude and a direction.
Angle.
Picture with an angle. Excellent. So if we want to duplicate a direction, how might we do that? By duplicating what kind of a figure? An angle, right? So we've just defined, right, for constructions that measure is a 1D measurement, and we're going to be using line segments. And direction, we just said we're going to use, to duplicate that, we're going to use angles. So we've just done some definitions there just by using what we already knew and looking at our page. So great job. How about, I'm going to talk about authority here and testimony, because I want you to be able to connect this lesson with lesson 28. And lesson 28 is all about proof. And what we're going to do this week is we're going to use our tools, and we're going to do with drawings what we're going to do in lesson 28 with words. We're going to take different ideas that we've learned, and we're going to integrate them together to show that something is true. Right? So what we're doing is a type of proof. It's a type of authority or testimony of putting those ideas together. And because I don't have my phone in front of me, I don't have my time in front of me. So if you see me suddenly look panicked and look at my watch, that's why. So let's go ahead and look at our Memoria page. And I thought that we oftentimes talk about what to memorize and what does the arrangement look like. But this is also a great place to stop and practice our names, right? Our skills, our grammar skills. So let's go ahead and take a look at this page and what are some things that you might name?
Maybe the types of lines.
Yeah, so like parallel lines, right? Perpendicular lines, perpendicular bisector, angle bisector, maybe those. That's good.
You can name the congruency patterns for triangles.
Excellent. Yep. Mostly the words, right? The words that are on the page are the things that we would name, right? Those are naming these ideas. What's something that we might want to really attend to well on this page?
I think the symbols, because, if you have equal lines or equal length, you have the notation of that denotes that it's the equal length in the triangle. I'm looking at the second column.
Yeah, excellent. So all of those labels are going to be really helpful that we really want to attend to. So in that second column, you're right, there's lots of tick marks to show things that are congruent to one another. On the left-hand column, we have those little arrows that are showing the lines that are parallel to one another, or the lines that are perpendicular to one another. So those markings really matter. And so those are things we would want to really attend to closely as we're looking at this.
Something I want to attend to is to note for everyone is that it says that reference C28. This is one of the few places where, so we're at week 14 and we want to point you to a later lesson because 14 and 28 are very connected. So you won't see that very often because we tried to stay true to where we were in the lesson, or I should say in the scope of the year or the sequence of the year.
I think I would want to really look at the vocabulary and what they mean. Sorry, my video is not working for some reason. But I'm wondering about like taking time to actually define all of these words and maybe make this lesson take more than a week, because it's 14, so we have a little bit of break, right? And she'll need to know what each of these things actually means over the course of the next few years. So if this is the first time, this will be the first time we're looking at some of these terms, I feel like 1 week is not enough for us to do all of that. And so I would definitely be like, let's look at each term, maybe not all of them, but let's take 3 or 4 of them that we know will be in week 28, which I would go look at. And really take some time to define those.
So you should, just to be clear, you should have seen, I think all of these ideas you will have seen in lessons 11, 12, and 13.
Okay.
But you're going to look more specifically. A lot of these come out of the proofs that we've chosen for lesson 28. So when you look at lesson 28 and you look at those proofs, these are some of the things that we're actually going to prove or we're going to use in those proofs. And so these are some of the images. So that's that connection. But yeah, this is a great place to come back and go, okay, so we've seen some of these, they maybe didn't stick the first time. So let's take another look. And you're right, you do have extra time to maybe go back and look and say, okay, where were these things in those other lessons? if we don't remember seeing them. So remember, names is naming, attending. What's the M stand for?
Memorize.
Memorize. So we could work on memorizing this whole page, and over time we may do that. But for your first time through, right, what's one or two things that you think, oh, I think I would really like to make sure my students memorize that their first year?
Well,
I would want to point out to them the boxes for 90 degrees and the ticks on the right, because if they don't see those boxes or ticks, they can't assume a shape is drawn to scale, and they can make mistakes. And those seem like two things that help you not make that mistake.
Good.
I had something kind of related to that. I noticed that you have on the right-hand side where you have the two triangles beside each other, there's a similarity for angle, angle, angle. All the others have congruence relationships. And so once again, like you can't look at those two, I could look at those two triangles beside angle, angle, angle and say, oh yeah, they look like the same size. But we can't make that assumption if we only have that information. And so I feel like this is a play, like I've learned these things, but like seeing it all right there, like, oh yeah, 4 of those are congruent and one of them is just similar. Like that's a good thing to memorize at this point for my high school students.
Excellent.
And I think those things are sort of universal in math. So where this may look very different than math they've had before, whatever math they have coming, when they see that box being 90 degrees, that's kind of really like it's going to carry them past homeschooling.
Yep, excellent. Yeah, none of these things are unique to the math map, right? These are mathematical ideas, and they're communicated in a mathematical language that is, yeah, you're right, universal, right? Global. It's definitely more than just the math map. So E stands for what?
Expressing.
Expressing. So what might we express? When you think of expressing, what do we usually have to do?
You might have them draw or trace them or find them in different places in the house and note it, like say it, like here's a triangle, here's a rectangle, maybe something where you're.
Yeah, that's what I was thinking. That's great. Right, so I could say not just copy, but I could say, okay, draw, right, 2 congruent triangles and show they're congruent because of side, side, side congruence. Right? And then how about our last one? What's the S stand for?
Storytelling.
Storytelling.
Storytelling. Anybody got any ideas for that?
I think that when we talked about what Lee and Jana said about that you have to trust the symbols, you have to know that 90-degree angle and what those tick marks represent, that I know that we've talked about this, lots of times, that you have to have an authority. And so when we have an authority that we can trust, then we can trust that part is true, and we don't know everything we're looking at. So I think it relates really well to lots of Bible verses about walking by faith and not by sight, or trusting the Lord more than you trust whatever's happening around you, because his word is true. Like that symbol points to what is true.
I like the idea. My kids told me a kind of a thing. I don't know if it was a story, but they were saying how, like, if you point an airplane 1 degree to the wrong place, like in a different direction, then you will end up hundreds of miles potentially from where you intended to go. And so this idea of like having that box right there or having that tick right there about being exacting relates in that way. That's like, hey, you could have an angle that looks like a right angle, but it's 89.9 degrees. It's not a right angle unless it has that square in it. And just teaching them to attend to the details, because just like that airplane, if you move it just a little bit, the destination changes. So I thought that was pretty good.
Great.
What is that on?
Like cartoons.
All right. Excellent. So let's go ahead and take a look at our first two. Oh, Michelle, sorry, go ahead.
Uh, it, Hi, Kirsty, if you could go back to the Memoria page. Was attending that right-hand column and I was seeing the angle similarity. Oh, okay, you can abbreviate it AAA. And then that was consistent all the way down. But then I got to CPCTC and CSSTP, and I'm sitting here going, what does that mean?
So CPCTC means corresponding parts of congruent triangles are congruent. And
Okay.
CSSTP means that corresponding sides of similar triangles are proportional.
Okay. Thank you.
You're welcome.
Find that. Where would we find that? Is that in the charts?
Yeah.
I'm assuming I haven't looked at it.
It should be in your charts. Yeah, it should be in the chart chart 12.4. You'll see it again in 28, and hopefully it's also in the glossary.
Oh, cool. Thank you.
Welcome. Good question. All right, so as we look at our charts, we're not going to look at the last page of the charts, although some of your students might find that last page is the most fun because it's geometric drawings and it's there for them to just practice using their tools. So this is those last 4 pages are a great opportunity. You may even want to start with those your first year because they're a great place for your students just to practice using their tools. But I want to talk about looking at the charts. I'm just going to talk for a minute rather than turning it over to you like I usually do, because I want to point out that there are 3 main kinds of constructions that we're going to look at. And we're going to look at the same constructions year after year after year. These are not the only constructions that you can do, but they are some of the most common constructions. And if your students learn these constructions, they'll be able to take those skills and apply them to constructing other things. The most recent of our construction techniques are the patty paper constructions. And so in a minute, we're going to change the camera so you can see what it looks like to work with the patty paper. But it is literally, it comes from the idea that it's the paper that's between your hamburger patties. Most of them, but you do have to pay attention because most of them are square cut. But if you sometimes you can buy a box and it'll actually not be square. So if you're buying it on Amazon, look at the measurements because square cut is helpful. Not necessarily necessary, but it's helpful. It is nice because what happens when you fold it, you actually can see the crease of your fold because it's kind of got some wax in it. And so you'll see the crease where your fold is. And it's that folding that is going to help us to do some of our constructions. So we can trace with this. You can use this for origami. So it's really a great tactile tool for constructions. And like I said, we're going to introduce you to some of the things that you can do with patty paper. There's certainly a lot more that you can do as you work through it with your students. But that's patty paper. That's where its name comes from. You can usually get about 1,000 sheets for about $10 on Amazon. So you could go in with a couple of families if you wanted to, or just get a box and know that you're going to use it for the next few years. So patty paper. The next type of tool that we're going to use is the double-edged straight edge. It does not have to be a ruler. In some cases, it may be better if it's not a ruler. So for example, here's a bookmark that I was given, right? And my edges are parallel and there's 2 of them. And so that is my double-edged straight edge. I'm not going to use this to measure. I'm going to be using it simply to draw parallel lines. So that's my double-edged straight edge. Usually your rulers are going to be double-edged straight edges, but it can be anything. one of the great things about the double-edged straight edge is that it's a simple tool to have, and even to kind of manufacture, right? So I'm just looking at things that are on my desk, right? Here's a watch band, double-edged straight edge. Here's a nail file, double-edged straight edge. I could even take my patty paper and fold it in half and create a double-edged straight edge. So this is a tool that I could have almost anywhere. And so you'll see if you read that little section there about double-edged straight edge, that actually there was a book printed about double-edged straight edges being so great because they could be done on the battlefield with very simple tools. So when we talk about being accurate, right, where we're sending our cannon fire, important to be accurate. And so these constructions could be done there with simple tools. And then our last tool that we're going to see that we're going to use is a compass and a straight edge. Again, we usually use rulers, but they don't need to be rulers. We're not measuring anything in the conventional sense of using units. We just need a straight edge. And then my compass in this case is what I'm going to use to be drawing circles. So you can use this style, or I should have pulled it out because I had it here and now I don't see it. But there's another style that may be easier for little fingers called the safety style compass. And that's helpful because you can actually like stick your finger on it and move it around. So there's different tools you can use. There we go. Thank you, Jill. Jill just showed you a safety style compass. Or if you were out in your yard and you wanted to construct something, you know, for a flower bed or whatnot, you can actually use a piece of string, right, and a stake and make huge circles. And a piece of lumber is your straight edge. So we can scale these to lots of different applications. So those are the three kinds of tool sets that we're going to be looking at this week. You're going to notice as you walk through this that a lot of the work is there for students to sort of copy the steps onto another piece of paper. They're not this yet expected to just do the constructions themselves. They're going to be practicing these every year with the goal that by the time they are in the expressions and transcendentals year, that they'll be ready to do these constructions themselves and then ultimately apply those skills to other constructions. So I just wanted to really emphasize that nobody expects your students to be making perfect constructions this year. You're going to be introducing the tools to them, introducing the idea of construction, and then completing them on the page, and then working on a separate page to copy some of those steps. So as we look at the charts, are there any comments or things people would like to share as they've looked at these charts? Or is there anybody on here that really feels familiar with constructions? Is this something that you've done before?
Kirsty, this brings back a lot of memories because my sixth grade elementary school teacher, he made us every day for the whole year use our compass and design different constructions. So this brings back a lot of mixed memories, but it was really a very, I mean, we got better and better and we began to see more and more patterns of math. So that was kind of cool.
Excellent. All right.
I just think constructions feel hard because we're so used to math having numbers next to everything. And what's so interesting is that constructions allow you to prove things are true, whether it's an inch on your table or from here to Saturn, the math still works. And so removing the numbers helps you kind of believe that it is going to be true every time.
All right, so let's go ahead and take a look at our pages here. And so we look at page 1, and we're first, right? We always want to stop and read. So if we look here, the title is PP1, and that goes back to the chart. All of these constructions are in the chart, and so they're named. So PP is patty paper, number 1, and we're working on constructing the center of a circle. This may be one of my favorites, just so you know, not that you need to know, but I love the fact that you can actually take any portion of a circle and you can use your skills here to find the center of that circle, right? So even if you don't have the whole circle, you can still find what would be the center of that circle. And I don't know why I just think that's the coolest capability to have, because there's a lot of times we want to know something like that. And so anyway, you're going to be empowered. Then underneath that, it says read, and it says the general order of steps in the drawings, folds, constructions is red, green, then blue. And the tools needed are patty paper, a compass, a double-edged straight edge, and a pencil. And so what we did is we have tried, right, with all of these lines and in 2D, we're trying to show you the order of the steps. And so red is generally the first step, green is that intermediate step, and that last step will be in blue. So sometimes you won't see the blue because we're leaving that for your student to do, right, on the exercises. But that is our goal. As you look at those, that's how we're demonstrating this. So then those are general for all of our construction pages, not just page 1, but for all of them, that's true. Then our next instructions say use a compass or a round object to draw a circle anywhere on 3 pieces of patty paper, and then fold the patty paper to match the dashed lines. So there's another piece we're going to read here that says the dashed lines indicate creases created by folds. So, and notice then the blue point is the center. So that's the last thing that we're trying to do is find that center. So we're going to look at 3 different things here. We're going to look at folding the patty paper in half and comparing that to folding the circle in half. We're going to look at using 2 diameters to find the center. And then we're going to look at using 2 chords to find the center. So I'm going to spotlight my other camera, and hopefully this will work for everybody and you can see it. So if you have your tools, you can follow along at home. So I've got my patty paper here, and I'm just going to use a bottle, and I'm going to trace this to get my circle.
I wonder if you would stop sharing your screen, like we could see you bigger. I don't know if you want us to be able to see the, yeah.
Okay.
Oh, yeah.
All right. So I'm going to trace to get my circle. And one of the reasons why I like tracing for this exercise is because I don't know where the center is, right? And so that makes sure that I'm not cheating. But our first exercise really is to encourage the students to see the difference between folding the paper in half and folding the circle in half. So if I take my patty paper and I fold my patty paper in half, right, I'm going to line up the edges of the patty paper. And I didn't do a very good job there because it's almost as half of my circle, right? So I didn't mean to do that. But now I'm going to go ahead and fold my circle in half. And it doesn't have to be parallel. We're just really trying to emphasize that these are 2 different activities. So to fold my circle in half, I'm going to lie that circle on top of itself. And I can actually see, hopefully you can see here. Bring it a little.
First, if you folded your paper in half the other way, your lines wouldn't have matched up.
I know. I didn't think about that until afterwards.
Well, that's okay. It's all experimenting, and that's just a good idea to show the students. If it's too close, do it a different way.
So let's go ahead and do that. So we could see there it didn't line up, but now if I go ahead and I fold it this way, right? And then I fold my circle that way. There's the difference, right? That this was half of my paper and this is half of my circle. And you could even, because we just want to practice folding things in half, right? You could even encourage your students to fold their patty paper in half this way, right? So folding seems like a really easy activity, but if any of us know, right, when you really are trying to fold something in half, it's not as easy as it looks. So don't worry about taking, if you don't get anything done this week, but if you get your kids just folding paper and being accurate with their folds, that's a big skill to practice.
I like too how you traced, because in the past I have had kids who had trouble with the compasses, and even the easy ones, that the one that Jill showed. And so I've just brought in lids of stuff for some of them, so they could have an option, right? And so I think having all those tools available helps the students not feel inadequate if they just get to choose whichever tool they want.
That's a great point. So I'm going to keep using my vitamins here. And I'm going to trace another circle.
This is also a good, if you have a bigger class, a good place where you might want to put them in teams and tell one group they're going to do the first 4 pages and the next one, the next 4 pages, and have them do all 4 types of constructions as a group.
Yeah. So the next one was to take and fold 2 diameters. So this is where you may want to go back and talk about what does a diameter do, right? It's going to fold my circle in half. So remembering from our first exercise, we're not folding our paper in half, we're going to fold our circle in half. So I'm going to go ahead and I'm going to take my patty paper and I'm going to fold my circle in half. There's 1 diameter. Now I'm going to fold it in half another way. And as I fold it in half another way, right, this is where we can see now that there's an intersection between those 2 diameters. And I'm going to take my pencil and mark that so that we can see it, right? That is the center of that circle. So I didn't know that beforehand because I didn't use a compass to draw it. So I took, I took a shape that I didn't know the center of, and I found the center.
The other application of this lesson is, if you remember 13, week 13 has a lot of circles with lines through them, and we look at their relationships. And so this would be an opportunity to build all those relationships from 13 rather than just follow week 14's instructions.
So now I'm going to go ahead and I'm going to use a different thing to trace. And I did that. I know that's hard to see. I'm going to go a little bit darker here. Because I wanted you to see this is a case where I don't have the whole circle. So I can't just fold my circle in half. Okay. So I have a portion of a circle and I want to know where was the center of this portion. So what I can do is, this is going back, as Lee said, we're taking these ideas from previous lessons and now we're putting them together. This is probably the most advanced because what we have to remember is that we can fold chords, that chords are just any segment that go through 2 points on my circle, and that the perpendicular bisectors of chords are diameters, right? So I can't just fold in half to find a diameter now, but I'm going to make 2 folds here, and it doesn't matter if those folds overlap. You do want to try and make sure those folds are not opposite to one another. So I'm just going to fold twice, and I'm going to trace this just so you can see what I'm doing, right? So here's one chord, and here's my other chord. And I want to go ahead and I want to construct the perpendicular bisector. So the perpendicular bisector, I'm going to take those chords and fold them in half. And so as I fold that one in half, that's going to create 1 diameter. As I fold the other one in half, right, and there we go. Where those 2 diameters intersect, that's the center of that circle. Isn't that cool? Like,
Very
I just
cool.
like I just really think this is the coolest thing. So you might not get to this with your students this year, right? But we're building towards it. So it's okay if you say, hey, this year we're going to practice folding paper. And then maybe you say, okay, well, we practice folding paper, so I think we can do this one. Maybe you get to this one, or maybe you don't. And that's okay, because you're going to see this in subsequent years to build up that skill.
I love that there's ways to do it without using the tools, because there are kids who just the physical work of using the compass or those things, it might be a challenge for them for different reasons. And so it's nice that there's more than one way to do it and to just have it all out there for everybody.
So I really enjoy Patty Paper. I think that it's a really friendly construction tool for that reason. So I am not going to spend a lot of time today on compass and straight edge constructions because we usually just look at the first couple of pages. But I do want to go through one of our constructions here, and I'm actually going to. Thought I could do this without, but I think I actually have to turn this. I'm going to have to stop presenting. And share my screen differently. Okay, because now I can use the tool here. I'm going to use the ruler. So here I start with my segment AB, and here's my double-edged straight edge. And what the double-edged straight edge does is we're going to line this up here because we know that the points are equally distant wherever they are. So notice here, I can lie this so that the ends of my segments lie on opposite sides of my straight edge. And then I would trace. Now, the directions show you drawing it all the way along. I'm going to draw just a portion of it here, and then turning our double-edged straight edge the other way. So that I just go through. And now I'm going to draw along those edges the other way. And so if I move this out of the way, you'll see I end up with these 2 crosses, and that's what's here and here. And what we've constructed are points, I'm still trying to draw on there. What we've constructed are points that are equally distant from that line. And and from the endpoints. And what we know about the perpendicular bisector is that it is equally distant. All the points on the perpendicular bisector are equally distant from my endpoints. And so by constructing 2 of those points that are equally distant from my endpoints, when I connect them, I end up with the perpendicular bisector. And so this here, that's perpendicular, and it bisected. And so that's what we're doing. So you can see here at the last, all we're asking them to do is to trace. But if they want to try and do this on their own, right, that's what we're doing with our double-edged straight edge. The double-edged straight edge constructions tend to build on themselves. So you'll notice that some of them you have to actually come back and maybe do this construction in order to construct something else. So they tend to build on themselves in a way that the other constructions don't. Once you start to get familiar with using the double-edged straight edge, they're actually really fun to do, but I also think they're probably the most unfamiliar to us of all of our construction techniques. So.
Also with the double-edged straight edge instructions and the digits through reals, no, through just the rationals. Some of the steps are left out, so the students would have enough room to practice the beginning steps and actually do them right on top of the paper. And so if you go, this didn't finish, if it didn't get you to the title, like the DE one, that's why. But as soon as they hit complex, all the steps are there.
And again, just as Lee was saying, right, our goal is to eventually have the students do these, but you all know that at different ages, our students are all in different stages of development. And so some 12-year-olds are really, really handy with their straight edge and holding a straight edge down and drawing along the end of it. Other students, right, they start to draw along the edge of that straight edge and it moves on them. So it may be that this year, all you're practicing is really being able to draw a straight line using a ruler, right? Or maybe it's just drawing circles. That's where some of those art pieces that they're going to be doing on the floor set are going to come in to play, of really just practicing using those tools. So, of course, then we finish our week with our logic catechism, reminding our students of all of their tools, and then reminding you. So just, Lee and I were talking, we had planned originally to go through lesson 17. She did say, you know, do you think we should go through 18 and finish up 2D, or come back and pick up with 18 in January? So if you have strong feelings, feel free to chime in on that. But as our schedule currently stands, we would finish up with lesson 17 on November 20th. We would not meet on the 27th for Thanksgiving. And then the 3 Wednesdays in December would all be just open Q&A times. So, and then we would miss the next 2 weeks for Christmas and New Year's. And so it would be January the 8th is when we would be doing lesson 18. But if you guys would rather have that before Christmas, we can make December 4th that. So if you have a strong feeling, feel free to chime in. And that brings us to the time for questions. So what questions do you guys have?
I think I have a simple one, I'd like to believe. So can you help me help my children understand, like, can you give me an example of when it would be important to find the center of a circle? Like, why are we practicing these skills to find the center of different, I mean, not even a circle, I guess, but.
So I'm going to give you 2 answers. One is that, right, the purpose behind constructions isn't necessarily practical, that we practice constructions because they help us to connect different mathematical ideas together, right? That in doing constructions like we do with proofs, the goal is really to integrate different mathematical ideas, demonstrate relationships, or discover relationships. But for me, like, if I practically, you know, sometimes we want to be able to measure the radius of something, right? And you know that something is circular, but you're like, I want to have an accurate measurement of the radius or the circumference. Well, if you don't know where the center is, then you're just estimating and guessing. But if I can find the exact center, now I can actually measure that and calculate the area and know what the radius is and calculate the circumference. I mean, I think about, like, outside, you know, sometimes you'll see where there's a circular bed, but was cut at some point and you want to put a tree or a plant in the center, but maybe you don't really know exactly where the center is. And we all know that you might think you've made a really great estimate of the center, and then you step back and it's just a little bit off and it drives you crazy. So, right, that's where I think about it in like in a landscaping sense, right? I can take that bed that I know is circular and I can find out, well, where is actually the center? I mean, I've used it for cakes, I've used it for all kinds of things like that.
Kind of real practical and immediate use for your children is lots of folks who are able to use patty paper are at the age to draw a little bit better than a preschooler. And if they can, in their minds, or even actually fold the paper they're drawing on, they can make the sunshine rays be more accurate, or they can make the proportions in the art that they're drawing radiate around something. And so it's just a simple tool that would help a 9-year-old draw more like a 19-year-old. And there's a lot of satisfaction then in the art they produce.
Okay, I do have another question. That was really good. Thank you. So when we're doing the finding the perpendicular bisector, is this the same as like if you measure the segment and then divide it by 2 and draw a perpendicular line? Is that what you're constructing?
That's exactly what I'm constructing. But you know, if you, right, so let's go back and let's talk about significant digits for a minute. Why do we have significant digits? Who remembers? Why do we use significant digits? Why do we care?
For accuracy?
Because, right, have you ever had the case where you measured something and you knew, right, that is exactly 10 centimeters? Or, right, even just when you look, right, like if you look at your ruler and you look at the line where 10 centimeters is, and that little line there is a lot more than just 1 point, right? So even if it came right to that line, is it at the very beginning of the line? Is it right at the very end of the line? Right, we never know exactly when we're measuring something. We might be close enough, right, for us to be confident with it, right? If I'm measuring for, you know, carpet or something like that, do I need to be super exact? No. I might be happy to say, well, that's 10 centimeters, but there's a degree of error. Anytime I measure something, there's a degree of error in it. And the easiest way we can think about that is just to think about the number line, right? When you think about, okay, here's my number line, there's 1 point that's exactly 10, right? A point to the left isn't 10 anymore. A point to the right isn't 10 anymore. We can't necessarily practically see that. But when we think about a ruler, right, we start to see that we are definitely in the case where we're not exact. So I might measure something that's 10 centimeters, half of that is 5 centimeters, but as soon as I start measuring it, I'm introducing error. Whereas if I construct it, I know that I am exactly bisecting that line, right? And I may not even be able to visually see the difference between measuring it and constructing it, but I know when I'm constructing it that it's exactly.
Interesting. Somebody is typing away. Oh. Okay, that makes a lot of sense to me. So it's really about it's kind of like a double check, right? Like you could estimate it, but if you construct it, then you're double checking to make sure to check for accuracy.
Yes, right. So constructions are always going to be your most accurate representation of a geometric truth.
Okay, most accurate. Thank you.
Hi, I have a question.
Yeah.
I am in book 11, page 11. And I was struggling with discontinuity. I didn't really understand like circling the infinite, removable, and jump. I thought I was getting the patterns and then I wasn't getting the patterns. So, and I couldn't find any videos online that could help me with this one.
Sure. So I will let you know that there's a known error. I'm going to stop sharing this page and I'm going to start sharing a different. I lost you all. Come back. So there are 3 different types of discontinuity, and one way you can think about a discontinuity is anywhere you would have to pick your pen up, right? And so that's a simple way to explain it to students. And we're going to see one kind of discontinuity is an infinite discontinuity, and we always see these with asymptotes, because what happens is as my graph gets ever closer to that, it's going to infinity. So we say it's an infinite discontinuity because infinity is getting in the way, right? Then we have our jump discontinuities. Literally, our graph jumps. And we see this most commonly with any kind of piecewise function, because I might say I have one function that goes to here and my next function starts here, right? And so a very common function is called the step function. And the step function essentially returns the integer. And so it's used a lot in computer science if you want to take any number and then say, I just want the integer. So it'll say if it's between 0 and 1, it equals 1. And then at 1 to 2 and 2 to 3. So that's called the step function. It's still a function because there's just a one y value for each x value, right? Because these are open circles and these are closed. But it's a discontinuity, and it's a jump from one to the other. And then the last kind really shows up when we have x squared over x, right? If we looked at this here, we know that x cannot equal 0, right? It would be undefined at 0. But we also know we could simplify this to x. And so we would have a circle here, and the rest of it keeps going. And so my discontinuity is just that one single value that's not defined, the rest of it is. So we call that removable, because the easy way to remove this is to say, right, when x equals 0, f of x equals 0. So we essentially make it a piecewise function by coming up with the missing value there. And so that's why we say it's removable. I'm guessing that maybe you had a question because the fourth problem on that page looks at, there's 2 on there, and based off of where x is approaching -2, that would be an infinite one, but the answer key shows removable because it's looking at the other one. So at x equals -2, it should be an infinite discontinuity, and at x equals 2, it would be a removable discontinuity. So does knowing that help to clarify that for you?
Yes, it does. Thank you. And I couldn't find another page with the same material, so I was so confused. So thank you.
That's it. You're welcome.
Hey, Kirsty, I had a question about the f of x. So is that f stand for function?
Yes.
Okay, all right. But we don't have to say the function of x. We just say f of x.
Yes. But, so I will say this. So it does come from function, right? That, right, I can say y equals some function of x. And we use f most commonly because f for function. But I could also say g of x or h of x or k of x or whatever other letter I want to name my function. And so those could be 4 different functions there that all just have different names. So just to clarify there, but we would always just say like g of x, h of x, k of x, but it's standing for some function f of X, right? Some function G of X, if you wanted to think about its long name.
Okay. All right. So that F that you drew in the second demonstration, or where you had F, G, H, K,
yeah,
that's actually, that F is different than the one when you said when X equals 0, F of X equals 0.
No, it's the same. I'm just saying, like, most commonly we use that F there for, because that's just it stands for function. So that's just the most common. But if I had more than one function, or you might see in some other places people prefer different letters, we can use different letters and they all mean the same thing. They're just naming different functions of X.
Right.
Yeah.
But the way you drew that F is different than the one when you said Y equals F
that's
of
just
X.
my handwriting. That's just me handwriting
Okay.
things differently. Yes.
Okay.
No,
All right.
they're
Because
the same. That's just, sometimes we make a pretty F. Sometimes I just write F. That's just me being inconsistent. And
okay,
I apologize.
No, that's okay. Because really my question has to do with that, your pretty F, because in the notations cards, the flashcards, there is that quote unquote pretty F. And I'm just trying to be clear about what the role is between those two different ways of drawing the F.
So usually in the math map, we use an italicized F, which is more, right, I would say this is more like the italicized, and that's usually what we use in the math map, just to be clear. But it doesn't, yeah, we're trying in the math map. Usually you'll see that italicized F when people are talking about functions. But when people go to handwrite, all bets are off.
There is also a flashcard with a capital F of X, but that's something different.
Yes. So the capital F of X is specific to the integral, right? Or the antiderivative, which is also the integral.
Okay. Yeah.
So it's kind of a specific function, but we won't go down that path just yet. We've got a few weeks yet.
I have I think a silly question, but is there a particular type of compass that we should get as the kids begin to practice using the compass? Is there like certain notations on some, or is plastic worse than steel, or like, do you have any recommendations there?
So the ones that Lee has in the office that we use, I'm going to just kind of hold this up so you can see it. It has a wheel here, and that wheel does help to hold it steady, so you can be a little bit more precise. And then if you don't touch the wheel, it'll stay that distance apart. So that little wheel does help. A compass is probably one of the things where you get what you pay for. So if you get a cheap compass, right, those plastic compasses, they can be more frustrating than it's worth. So a metal compass, one with that little wheel, is probably one of the easier ones for students to work with. We call them a divider style. So dividers actually don't have a pencil because they're just used to measure distances, whereas a compass has the pencil lead in it. But it's a divider style because it has those two sort of scissor kind of idea that move apart those two legs. So that when we talk about a compass, we usually mean either the divider style, or again, as we mentioned, that safety compass, which may be a little bit easier for little fingers because you can actually like hold the part that's turning. The drawback to that is that it's all little holes, and so you have to remember which hole you're in to draw your circle. So there's pros and cons to different things. But again, when it comes to a divider style, you do get what you pay for. Yes, Wendy, I like that. Cheap compass, bad circles.
Okay, cool. Thank you.
You're welcome. Other questions?
I don't have a question, but I had a little math moment this week that I made me think of all of you guys is I was listening to an author, and he was obviously promoting his new book, but he is a cold case detective, and he was talking about with an apologist what researching these deaths or investigating them has taught him. And it was just, he used the illustration that in our minds, we usually see life as a line segment. And he said, but as Christians, we really should see it as a ray. And I just thought how after this season in the math map, that was much more powerful to me than had I just listened to it last year, possibly.
Oh, that's beautiful.
Yeah.
Thanks for sharing. Well, as ever, I'll be the last to jump off in case you have last minute questions. But next week we're going to be talking about assessment, and so I want you to think through, right? What have you learned from the beginning of the semester? I'd like you to really all sort of self-assess in this coming week and bring some of those things to share. How have you grown? And then as we look at how have we grown, what can that tell us about how we want our students to grow? Because I think there's some mold breaking that we need to do when it comes to assessing math. And so I think if we think about the ways that we've grown and developed, that might help us to consider how it is that we're assessing our students. So I look forward to hearing lots of testimonies next week.
Okay, then I have one more kind of, I don't know if it's a question, but it's more of a need to, it's more of an idea I need to flesh out. And I'm sorry, my camera's not working. I don't know what happened, but so I'm still wrestling with how much work this is for me as the parent. And I like it, and I definitely feel like if your goal was to make me smarter in math as well as my student, you're definitely reaching that goal. But I am still struggling with how many new concepts are being introduced every week that we have to like search for and look for and try and figure out. And then sometimes we'll look at the answer and can't figure out how to work backwards from that answer, even with the charts and things. And that gets to be discouraging, especially, at least 2 or 3 times a week, we're kind of getting stuck. And so I appreciate the diligence that it's taking for us to work through that. But I kind of need some language or maybe just encouragement around why does this still feel so hard?
Well, because it is. One of the things I read this, and I forget who it was that said it, but it was a sort of a modern day math educator that said it, and it really resonated with me. And he said, stop telling your students that math is easy, or that a concept is easy, or that like don't say to your students, well, folding the paper in half, that's easy. Because as soon as we tell somebody it's easy, if they can't do it, the problem is with them, right? And the reality is math is hard. And so you are seeing, right? We're jumping into the middle of the math map domain, right? You're jumping into the middle of the map. So it's almost like if you were to walk, I don't know, pick any city, right? I don't know why Jonah and Nineveh come to mind, right? But if Jonah walks into the city through the gates, and as he's walking through the gates, he's seeing the city, and he's hearing the language, and he's seeing the people, and he gets to the center of the city, and he gets to the king, right? He's built up some knowledge as he gets there, that then he may have used in speaking to the king, right? And then as he walks out to sit on the hill and pout, right? He's layering that. Well, now imagine if he'd just been dumped into the middle, and he hadn't had that opportunity to walk through the city, right? He's just jumped into the middle, and now he's like got to like pick up really quickly what's all the language that goes on in this court, what's this city like, and here I am talking to the king. Well, that's kind of what we've done, right? Is we've kind of just dumped you into the middle of the city, and you haven't had the time to sort of come in. Like, I parked my car and I'm walking into the city and I'm getting a little bit more comfortable with it before I get into the center. We've just said, here you are, you're in the center of the city. Well, there's a lot of reasons why we did that. And the number one reason why we did that is because we can support Challenge A directors who in turn can support their families in ways that we wouldn't really be able to offer support to foundations families, right? Those foundations tutors, it's just a different role. So we are able to provide support in a way that we wouldn't had we started with a non-challenge level. There's other reasons why. Another reason why is that the greatest need, right? Why does CC need its own math curriculum? Because we need to have a common conversation, right? Why are you guys in CC? You're there because you want your students to be able to have a conversation with academic peers about things that they have in common, right? That's why we read the same books. That's why we are doing science fair together. And so there was no, right? I mean, if anybody can show me a community that was unified with everybody doing the same math curriculum and the same lessons every week, I doubt that unicorn exists. And so there was no unity in the logic strand in CC. And that's what we're about, right? We're about having a unified conversation. So the math map, the need for that unified conversation was greatest in our challenge communities. So those are your two big reasons why we started in Challenge A with complex. Having said that, right, you're now coming in and we're saying, and here's everything you need to know about math, right? And it is impossible to get it in a year, but you all feel like you should be getting it in a year, right? And so we're wrestling and we're fighting and we're like, oh, like there's so many new ideas. And guess what? Next year, you're going to go, oh, this isn't so bad, right? Because there's not going to be so many new ideas anymore because you're going to have seen them. So this year is a wrestling year. And the best thing that I can really, the two pieces of advice that I would give, or I do give to tutors who are like, we're struggling, I say, go back to naturals, right? If you didn't do naturals first, whether it's as a parent, as a student, as a tutor, if you did not work through the naturals before you embarked on complex, you made your life a lot harder. And so the best thing you can do is go back and work through complex. Now you can do that alongside, right? You could say we're going to go back and we're going to do 4 pages of naturals, or the first day, I'm just going to tell my students do as much of the naturals as you can. And then the second day, we're going to maybe look at fractions, or we're going to jump right into complex. Working through the naturals is the best way you can be prepared to work through complex. So that's the first thing. And the second thing is it's okay to say, we don't have to get all of this year. And one of the things you can do is if you look at those pages, right, and you notice that 1, 5, 9, and 13 have similar problems, and you go, oh, maybe 75% of those pages, it's all the same kind of problems, but then there's these like one-off little boxes. Think about how your pastor talks when he's preaching and he says, guess what? There's so many different one another's in the Bible. Do you think that's important? And we all go, yeah, God says that a lot. So it must be really important. So those ideas that are repeated on every page are probably the ideas that are more important than the things that are in the one-off little boxes. So if you get to one of those one-off little boxes, I'm not saying those ideas don't matter, but if you're like, oh, I really don't get this, it's okay to say, hey, I'm just going to like put that aside because we're going to see it next year. Because the way this is mapped, you're going to see it all again next year. And next year you might get to that box and you might go, oh, wait a minute, I think I remember something about this. Pull out last year's booklets if you still have them, and you might go, now I see how these are connected, right? And what this was building. And now I'm ready to wrestle with this because the rest of the page is familiar to me. So now maybe I'm ready to wrestle with this idea. So I really want you to feel like it's okay to say, you know what, that didn't make sense to us. We didn't see the pattern. We're going to skip that and move on. I mean, Lee is always talking about, right, make the book work for you, right? You don't work for the book. And so it doesn't have to be linear. I don't have to start at the top of page 1 and work to the bottom and then page 2. I can go through and say, right, you could say to your student, just go through and do everything that you're capable of doing without me. Right? The first 2 days, you go do the problems that you can do. And then we're going to go back and we're going to sit down and we're going to just look at the things that you couldn't do on your own and see if we can figure them out together.
That's good.
Right? And
because it is hard. I mean, how many times that I have to say, don't worry if you don't get that. Don't worry. At some point, the kid is going, Mom, I'm worried. I'm not getting a lot of, like.
Right. And I get that. And I do get that. But you know what? It's kind of like reading the Bible, right? So one of the things that we can learn from that experience is that we don't learn everything the first time through, right? And I'm not going to have you raise your hand, but how many of you have read the Bible through in its entirety? You know, you've read every single page, every single verse. You've read that. Maybe you've read it 4 times. And then the 5th time you go through and you go, I did not know that was in the Bible. How did that get in the Bible? I've read this before. Why did I not see that before? Right? There's always something new. And so, right, the first time we read something, we think we've read everything and we maybe understand everything, but we don't. And so we're learning here to go, okay, I'm going to learn what I can. I'm going to look at things, but I can't understand it all the first time through. It's worth coming back to. And if that's true for math, how much more is that true for the Bible? Right? That reading it one time isn't enough, right? We're building up this discipline of coming back and revisiting and revisiting and revisiting. And I don't ever want to equate the math map with the Bible, but I do want to equate those classical skills and those disciplines of learning, right? Those disciplines of learning that are true about the math map are going to be true about scripture, only more true, right? Because God says he's there for us to meet him in all things, right? That all of creation was given to us. We were studying the Psalms recently, and it was really beautiful because like the first half, I think it's of Psalm 19, like the first half is creator God and talks about references. Well, it doesn't reference because it's Old Testament, right? But it points towards Romans 1, where God says, right, that all of creation is there so that none has excuse. And that's the first way we encounter God. Then the second half of Psalm 19 is all about his law and his word. And it becomes the relational God, right? The noun that we use for God changes from being the creator God to the relational Yahweh. And so the first place that we're going to meet God is in his creation, right? That's where we meet him first. And he says, right, I'm here. And then where we get to know him is in his scripture. And so math as part of creation is one of the things that he's using to draw us in and teach him about himself and to help us learn how to come to know him, so that we're developing those skills that we then take into the study of his word, where we build our relationship with him. So I hear the frustration and I get that with our students, but I really think that there's a God's teaching us through that, right, about what it means to get to know him, and that we do have to come back and we can't get it all in one try. And we've been lied to, right? We have all been lied to for years because of the way conventional math is taught. We've been lied to for years that once is enough, right? It's a linear process and you only need to study greatest common factor one time in 5th grade and you've got it. And that's just a myth, and it's just a lie, because nothing is like that. All of our learning needs to be repetitive and layered. And so we're replacing this.
Well, and I feel like we use the greatest common factor so over and over again. So then my question would then be like, when is mastery, or what skills, when does mastery come in? Like when, I guess maybe it's the flashcards, right? Like, what do you work on that's like, you work on this until you've got it, versus I'm gonna work on this for a little while and then I'll get back to it next year, right? Like,
well, you're going to see a lot. I mean, I think as you work through the year, you're going to start to see more and more layers of, right, like just what we did. Like we talked about lines in lesson 9, then we talked about lines in lesson 11, then we talked about lines intersecting in lesson 12, and then we were talking about lines again in 14 and how we put them together. We're going to see lines a little bit then again in 17 and 18 especially. Then we're going to get to 19 and we're going to go, okay, well, what does a line look like in 3D, right? So we're going to keep talking about these ideas and layering these ideas. And I would say this year especially, we're looking for those big patterns, right? A line is one dimensional. Well, what does it look like if it's in 2D? Well, now I can spin it around anywhere in 2 dimensions and I can change its location. That's a big idea. Well, what does that look like in 3D, right? Mm-hmm. Maybe a student notices that the equation I can use in 2D doesn't work in 3D now, right? That's a totally different thing. So we're looking at these really broad pictures this first year. Over time, they're going to practice the computation and the algebra, and that's going to come together because they're going to have pegs to hang it on instead of, right? So if you go back to that old-fashioned CC idea, right, when we joined in 2009, right, I remember listening to a recording of Lee speaking about the pegboard, right, that we're pounding those pegs in, and then we come back and we start making connections. We historically don't have a lot of math pegs, right? And so that's what this year is we got to put some of those pegs in. We're not going to put every peg in the pegboard in this year, but we've got to put in, we're starting to fill that pegboard up with the pegs, so then we can start making the connections.
That's great. Okay, I have one final question, and then I'm gonna leave you alone. I have a second-year essentials student. So I have a challenge A, and I have a second-year essentials, and I have a foundation. My second-year essentials student is doing fractions this year. Next year, what will he do? Will he do fractions again, or should I bump him up to complex, and then he'll just do complex twice? Because he was doing 6th and 7th grade math already in 4th grade, and now that he's in 5th grade, I've bumped him down, kind of quote unquote, down to fractions. So what are you guys recommending?
So next year, I'm going to write this so that we can make sure we're clear here. Let me just move this over. So next year, for your 5 and older students, digits will be printed. For your 6 and older students, naturals will still be digital. For your 7 and older student, integers will be printed. For your 8 and over students, decimals will be digital. For your 9 and older student, you've got fractions that will be printed. For your 10 and older student, you've got rationals. For your 11 and older student, you're going to have reals. Those are both digital. Then you're going to have complex and monomials are going to be available
we're not
next
seeing
year.
your screen. I think you're trying to share. We only see each other.
Oh, huh.
I can see the screen.
I can see the screen.
Oh,
I can
it
see
just
the
left.
screen.
Okay.
You can see what she's writing? Okay.
Yeah.
Oh,
yeah.
I can't see what
Dr.
she's
Gilpin,
writing.
you switched over though and put the last 2 complex and monomials you have under digital. I think you meant those
thank
are
you.
physical.
Yes, you're right. Thank you.
Check your viewing screen, you guys, on Zoom to make certain that you're not just looking at speaker only.
Oh, I got it now. Okay, thank you.
Okay, so that's what will be available next year. So for your student who's going to be in their final year of Essentials next year, I would suggest doing Reels as your best, especially after fractions. So it'll be another digital lesson for them unless you wanted to buy the printed fractions. Which will be a little bit different to what's available because it's been updated. So you could do that printed fractions, or the digital Reels will be available for those students that have been in fractions and are looking for that, next step. Does that help?
Yes, I didn't realize they would be released digitally, the rationals and reels. So I will just print out the reels. And will it be available in April? Because they could do rationals. He could do rationals, a few of the rationals before the school year starts.
Yep.
And so to piggyback on that, then for anyone who will be coming into Challenge A next year and hasn't done any of MathMap yet this year, would you still suggest they go to naturals to try and do as much of naturals as they can before coming into complex?
Yeah, so they're absolutely welcome to, do fractions. We have a lot of families that are doing fractions, but the easiest entree in, right, is the naturals.
Okay.
And we have just overwhelming feedback from our pilot and from families this year that if you have at least done the naturals prior to coming into complex, it's almost a night and day experience. So yeah, okay. And I think because it's designed for 6-year-olds, for first grade, it's very doable. So there's a lot of families who could either do that alongside whatever else they're doing, or do that over the summer. It's just a much more accessible, than jumping in. But doing that prior to complex is definitely going to make a big difference.
That's helpful to know. Thank you.
I was thinking about, so I'm a Challenge A director, and when we do that window or catalog walkthrough that we're encouraged to do for those that are incoming, like in January, it'd be so good for those families not using the MathMap to start then. If they would start already in January with the naturals, that could be really
great.
helpful. Yeah.
Kirsty, will there be a companion separate for the monomials, or how is that going to be done? Will complex still be available, or how's that work?
Yeah, so if you go into the companion now, we actually are already building out the monomials for those pilot families. And so the goal is eventually every single domain you'll be able to click on and get the companion specific for that domain. Now, next year, you'll be able to do that for all of the printed versions. The digital versions, you'll get the digital lessons. I want to be really clear that the content for all of those levels will really be the same as it is for complex, except for those page tops. The page tops will be domain specific. It's probably going to be a little while before we're able to really start adding in domain specific equipping. But the chart content would be the same and so forth. But in time, you'll start to see more domain specific equipping in the companion. But at first, it'll just be those page tops that we'll be doing domain specifically to walk through.
And you were talking about in the companion, right?
Correct. In the companion, yes.
Okay.
So that's always been Lee's vision for the companion, is that, if Michelle says, okay, I'm working through fraction lesson 7 with my student, I want to be able to click on that booklet and look at that page and say what help is available for that page, right? That it's as close as we can get to me sitting next to Michelle and Michelle opening up her book and saying, explain this to me, right? Is kind of the idea behind the companion. And it's just going to take us a little while to get content for every single page, right? Every single domain. There's 390 booklets times 32 pages. So you can see there's a lot of pages of content to create.
Yes. Yes. Okay. Well, thank you. I appreciate that. That my son who's in foundations was doing naturals, but it just got to, he was just like dreading it because he was like, Mom, it's so easy. It's like, I get it. So we're still doing it, but I had to do more. So next year he can do fractions, and then my then 11-year-old will be able to do rationals and reals before heading into complex. And does that sound like that's
yeah, absolutely. Yep.
Okay. Thank you. I appreciate it.
You're welcome.
And then,
All right,
Kirsty, the
I'm
companion, sorry. The companion will always be available for all levels, correct?
Yes. The companion will be available for all levels. Yep.
Okay. Thank you.
You're welcome. Well, thanks, everybody. Have a wonderful week, and I look forward to seeing you all next week.
Thank you so much. We appreciate you.